Hello, and thanks for being here. I will talk about our work at FDL. FDL is a joint program between NASA and the SETI Institute. Here are some links if you want to know more about what FDL is and what we do. There is also a QR code with a link to a video made by Google Cloud that showcases FDL work. My name is Ivan Venzor Cárdenas, and I am a Mexican citizen. My background is in computer science. I have an MBA degree and a master's degree in astrophysics and a PhD in finance. I am doing a certificate in MIT. I currently work in the best bank in Mexico, and I was part of this year FDL. I also teach at Universidad Autónoma de Nuevo León, and my previous roles were at FEMSA, which is the second largest company in Mexico. What FDL is? FDL is an 8-week research program. There are some challenges within 4 domains. The domains are heliophysics, planetary science, earth science, and astronaut health. The Lightning and Extreme Weather Challenge is within the Earth Science domain, and our team was composed by 4 research members: myself, Neria, Merrick, and Maria. Our 4 core mentors were Mark, Clem, Samantha, and Gregory. The reason for our work can be seen from space. Here you can see the damage created by a tornado in Texas. Our goal is to create models to help forecasters to keep the public safe and save lives. In order to do that, we use GLM data. GLM is a lightning mapper on board the GO satellite, and it covers the whole Western Hemisphere. It works about 500 frames per second, and it measures about 1 million flashes per day. We believe that GLM data is currently underutilized for severe weather prediction. We build upon previous work. They shown that lightning is a precursor for severe weather events, and we build upon those works. We use heavily Google Cloud Platform. We had access to more than 200 CPUs and more than 10 GPUs. We use those to process over 3 million GLM files. Each of those has 9 channels at 1 minute cadence. We use both GLM files and NOAA severe weather reports. Those reports, we use them as our ground truth. We did significant preprocessing of the data in in order to have our models running. Here you can see some of the models we tested within our 8-week sprint. We tested CNNs, UNets, RNNs, 3D ComNets, com LSTMs, com GRUs, graph, eh, and also graph neural networks. Although we have some promising results, we didn't have the level of results that we needed for this challenge. But we explore also other ways. This problem can be seen also as a time series classification problem. Here we use the 8 GLM channels in order to produce time series, and those time series we could use them to classify the severe weather event. We we explore the inception time neural network, but we decided to use Rocket, which is a new method. Rocket doesn't learn weights like a neural network. It creates a lot of random convolutions. We tested from 10,000 up to 1 million random convolutions. Those convolutions are features which are then passed to a classifier. We built a time series model with 15-minute lead time. That that lead time is meant for the forecasters to issue the warning if needed. As now this problem is a time series classification problem, we have two classes. Our node class are those severe weather warnings that were issued by forecasters but that we do not have evidence that they produce severe weather events. And our positive class are those confirmed reports that we got from the NOAA reports. Using the convolutions from Rocket, we train a classifier to know if some events are severe or are going to be severe or non-severe based on these two classes. We compare our results to the state of the art. We use both the SAR and the FAR metric. Both metrics are widely used in the atmospheric sciences, and both are based on the 2 by 2 con- contingency table. Our results are promising, but we must note that the lead time, coverage, and period is better in their work. To summarize, we create a 15-minute nowcasting lead time series classification model using 8 GLM Lilin quantities. Our results suggest that we could decrease by 50% the false alarms, and that we could, in 8 out of 10 times, classify the severe weather reports correctly, events correctly. These results suggest that we can enhance and refine this work to help forecasters to save lives. For future work, we would like to extend this work to other regions and seasons, increase the lead time, and also use the ABI data, which is co-located in the same satellite. We would like to improve our computer models, our computer vision models, and to simplify our current pipeline. And we would like to use more GPUs other than the kind of training. We like to use them all over our kind of pipeline, and we would like to explore the transformers for the time series classification problem. We would like to test our kind of models at the NOAA hazardous weather testbed. Finally, we would like to thank many people that help us in our work. Thank you. And I would like to thank you for your time and for being here. Thank you and Please have a very nice day.